Today we're going to talk about graphing polynomials. Now guys, I have little doubt that if I gave you this equation that you could put it in your calculator and hit graph. Okay, I have no doubt about that. You have that skill. My thing is that I don't want you to be a button pusher. I want you to be a thinker. So instead of just putting this in the calculator, we're going to talk about some of the qualities, some of the properties of this. These are the things that I'm going to need you to know how to do. I need you to know how to find the degree. I'm going to need you to know how many turns there are. T-U-R-N-S. Sorry. And I'm going to need you to know the leading coefficient. And I'm going to need you to know the end behavior. Okay? Once you know all those things, you're going to be able to graph it. Now, it won't be an exact replica of what's in the calculator, but it'll be pretty close. Okay? So, looking at this equation right here, what do you think? What's the degree? What is it? 5, because the degree is the highest exponent. Okay? So, we're going to make ourselves a little note about that. The degree is the highest exponent. Okay? Now, is it always in the front? Well, it's always in the front if this equation is in standard form. If it's not in standard form, look through the equation and find the highest exponent. That's going to be your degree. Okay? So in this particular problem, our degree is 5 because that is the highest exponent. If the degree is 5, how many turns are there? Well, let's see if I can spell turns right this time. The way you find the number of terms is that you take the degree, whatever it is, and you subtract 1. So 5 minus 1 is 4. That's how many turns there are. Okay? Now, again, if this is in standard form, then our leading coefficient is going to be the first coefficient. If this is not in standard form, our leading coefficient is still going to be right with our degree. Okay? But find your leading coefficient. We don't care really so much right now that the leading coefficient is 2. What we really care about is that the leading coefficient is positive 2. The positive is going to tell me the end behavior, which we'll talk about in just a second. Okay? So leading coefficient. I didn't really have that in my notes to begin with to write that down for you, but somebody said, well, what if I don't remember what LC stands for? Maybe it means laughing chicken. Well, I guess that's fair because we do talk about laughing chickens quite a bit. So I just want to make sure you remember what leading coefficient was. Okay? Now for the end behavior. We know that our leading coefficient is positive. Once I know my leading coefficient is positive, I automatically know one of my end behaviors. Okay? When my leading coefficient is positive, I automatically know that this rises to the right. Because if I have a positive leading coefficient, then I know that my graph rises right. Okay? Or to positive infinity. It rises to the right. Okay? So I can look right here and know if my leading coefficient is positive, then it rises right. So I can go ahead and write that. It rises right. Okay, so all I have left to figure out is my left end behavior. Well, if it rises right, and I have 4 turns, I'm going to draw myself a little abstract graph. 1, 2, 3, 4 turns. Just look what happens to the left then. If it rises right and has 4 turns or changes of direction, okay, I'm going to go ahead and write that as well. A turn is a change of direction. Then it kind of you can clearly see that this falls left. So if it rises right, has 4 turns like this graph does, I just drew a little abstract graph and it will fall left. Now this is not exactly what it would look like in your calculator, except it is to the right and it is to the left, or to the positive infinity direction and negative infinity direction. It would be rising to the right and falling to the left. Okay? All this other stuff in the middle is kind of flexible, but this is just an abstract representation of it to help us figure out the left behavior. Okay? So the only other thing I want to write on here is in behavior, what if it's a negative leading coefficient? Remember, the leading coefficient only tells me the right behavior. So if it's a positive leading coefficient, it rises right. What do you think will happen if it's a negative leading coefficient? Well, it falls right. So it falls in the positive infinity direction. Okay? I think that's pretty straightforward. The only other examples I could give you are if the leading coefficient is negative, and we kind of just talked about that with this. I could give you a different exponent, so you could talk about different terms. But draw yourself a little abstract graph right here with however many turns you need, and you'll be able to see your lived behavior since you already know your right behavior based on your leading coefficient. Peace.